write our title is Encoder. So Encoder. So that's actually somehow clear from the name. So we actually, similar with the decoder, which we start with actually the smallest one, which was 2 by 4. For encoder, we do the same thing. The first thing is about the encoder is exactly the opposite of the decoder. So remember, in the decoder, usually you have 2 inputs, right? And 2 power n output, right? So, but in the encoder, you have 2 power n inputs. So see, I'm writing here 2 power n for the input and n for your output. So that means if I give the smallest one, which is smallest one could be 1, but we start with 2. So if n is 2, so you know, okay, the output should be actually 2. So this is 1, 2, and 2 power 2 is 4. And this is the 4 input that I have. So as you probably guess, I call this actually the encoder, which is, you could say, 4 by 2. So if this is the opposite of the decoder, in the decoder, the output was the midterm. So here the midterm should be input. So that means your input is your midterm, M0, M1, M2, and M3. Okay. So definitely there is it could be the enable pins, which is whenever that's active, it's actually the output is 0. Sorry, whenever that's active is do its normal job. Whenever that's deactive, the output is 0, no matter what you have on the. So, but for encoder, this is how it works. The first thing is in the input, you couldn't actually put all of them 1. In the one time, you should just have put one of them 1 and the rest should be 0. For example, if I actually put this 1 and the other 0, this is what's happened. If you label the output as a x0 and x1, so I give this 1, the rest 0, 0. So that means whenever this is 1, the other is 0. So then the output should be just a 0, 0. Okay. So maybe somehow you could use some table like this. And you say M0, M1, M2, M2, and M3. And you consider your output, which is x0 and x1. So see, just be careful. In encoder, you couldn't actually active both of them, put the 1 for both of them, because this is giving the corresponding codes for midterm 0. Whenever this is 1, all other is 0. It's actually give you code 0, 0, which is the midterm 0, right? So whenever it is 1, so definitely the code should be 1. Whenever M2 is 1, other is 0, should give you code 2, which is 1, 0. Whenever this is 1, all others is 0. It should be actually 2, 1. Okay. So exactly the opposite of the decoder, right? In the decoder, you give these codes and it's turned on the corresponding midterm. Here, the input is midterm. You turn on the midterm and the other should be 0. It's give the codes of that midterm, which is here is 0, 0, for M1 is 0, 1, for M2 is 1, 0, and for M3 is 1 and 1. Okay. So this is actually the encoder. So now question is how we could actually make these unit with the gates. Okay, so with the basic gates that we know. So for design this, usually this is the inside of these box. You actually put 4 line as 4 inputs that you have. So here we have 4. So you call this M0, should be M1, this should be M2, this should be M3. So then you actually put for each of these output, you just use one OR gate. So see, this is one OR gate. So I put for you could have for x1, this is for x1, and this is for the second output that you have. I call this x0. So then back to this table and check the column for x1. Whenever that is 1, just make a connection there. So here for x1, the M2 is 1, so should we have one connection here. And for M3, should have one connection. So you have same thing for x0. Check the table, this column, wherever it is 1, make a connection. It should be M1, and this should be M3. Okay, so is it doing the same job? Let me check. So if I give actually, for example, if I give the, for example, if I give, let us see, if I give 1 and 1. So if I give 1 and 1, sorry, if I turn this on, which is M3 is 1, and the rest will be 0. So this is 1, this is 1. Definitely these two output will be 1 and 1, which is right. So if I have M2 is 1 and the other is 0, M2 is 1 and the other are 0. So that means this should be 1, no connection for this, it should be 0, right? It should be 0. How about 1? So if I turn this 1, the rest 0, so see this is 1, the only connection here, definitely the output of this 1, and here all is 0, definitely give you a 0. And how about M0? If this is 1 and the other is 0, this is not connected to nowhere, so that means that both of them should be 0 and 0, okay? So this is how you could remember, what is inside this box. Just draw this table, then check if for each column you just put one OR gate. So just check which one is 1, just put the connection there. So definitely when we just consider these encoder as these box that you see here, but this is actually good to know how you could make technically with two OR gates, you could make the 4x2 encoder, right? So this is the encoder. So definitely you could make any other encoders. You could actually make, I don't know, what should be the next encoder that we could make. We have, so see, I give N1. So that means you have 2x1 encoder. It is possible. What if you give N here 2? So you have 4x2, which is right. We have 4x2, we made one of them. What should be the next? Definitely next should be N equal to actually 3, right? So that means you should have 8 to 3. What should be the next? We have 4, 16, right? So 16 to 4, 8 to 4, 4 to 2, 2 to 1. All of them is the valid encoder, right?